Hi, it's me, Paula, the math tutor, and in this video I'm going to be solving a problem in the style of an IB exam about binomial distribution. And in this example, we are going to be analyzing manufacturing of a product. In this case, it's light bulbs, but this is a very classic example where you can either have something that works or doesn't work. That's why it's binary, and we can analyze it with binomial distribution. So let's see the example, the problem. It says, two machines are used in a factory to make light bulbs. Machine A makes defective light bulbs 10% of the time, while machine B makes defective light bulbs 5% of the time. A randomly selected machine makes 10 light bulbs. Both machines are equally likely to be selected. Part A says, what is the probability that exactly 2 light bulbs are defective? Again, we have two machines. We're going to select one machine and then we are going to select 10 light bulbs from that machine, and then we're going to calculate the probability of 2 of them being defective. First, we need to see if this is a binomial random variable, if it's binomially distributed. And again, if you have some practice with binomial random variables, you kind of smell that it is, because first, we have independent trials. First item in our checklist, checked. They need to be independent. One light bulb being defective needs to be independent of the previous one being defective. Then, it needs to be binary. And it is, because I either have a functioning light bulb or a defective light bulb. Nothing in between. Then I need a fixed probability. For each trial, I have it. In machine A is 10%, in machine B is 5%. So I have a fixed probability of success. In this case, success is defective light bulb. And then I need a known number of trials, which I have because they tell me I'm going to pick 10 light bulbs. So the 4 items in my checklist work. This is a binomially distributed random variable. For machine A, I'm going to write that X is binomially distributed with 10 trials and probability of success 0.1. And for machine B, the probability of success is going to be 0.05. So X is binomially distributed with 10 trials and 0.05 as a probability of success. Let's calculate the probability of 2 light bulbs being defective. In this case, I have to calculate the probability of getting 2 defective if I happen to choose machine A, plus probability of getting 2 defective if it happens that I chose machine B. I have then the probability of picking machine A is 50%. It says that they are equally likely to be selected. So I have 0.5 times the probability that the machine makes 2 defective light bulbs, which in the calculator I'm going to calculate as binomial PDF with 10 trials, 0.1 as my success probability, and 2 as my value for X. That plus choosing machine B has a probability of 50%, so 0.5 times binomial PDF with 10 trials, 0.05 probability of success, and 2 for my value of X. I'm gonna go to my calculator to calculate that. I here have some things from previous exercises, but I'm going to write 0.5 times the probability that machine A makes 2 defective light bulbs. That I'm going to find in distributions here on top of the bars. Key, you have distributions and you activate it with the second key. Here I have the distributions of random variables and I want binomial PDF. I'm gonna press enter, and here the number of trials is 10. The probability of success is 0.1, the X value is 2. Now I paste it back on my screen. Now I want the same but for machine B. So it's 0.5, the probability of choosing machine B, times distribution binomial PDF. 10 trials, I'm gonna keep that. I'm gonna change the probability of success to 0.05 and the X value is 2. I'm going to paste it, and now I have everything I needed. I'm gonna press enter to see what result I get. And I get 0.134, and you can round it. That is the probability of getting 2 defective light bulbs, either by having chosen machine A or machine B. Let's go to part B of this exercise. It says, given that 2 light bulbs are defective, find the probability that they were made by machine A. So we have here conditional probability. We want the probability of choosing machine A given that 2 light bulbs were defective. The formula for conditional probability is probability of the intersection between the 2 events divided by the probability of the second one. In this case then, I need to calculate the probability of choosing machine A intersection 2 defective light bulbs divided by the probability of 2 defective light bulbs. The probability of 2 defective light bulbs, it's the one we calculated in part A, so it's 0.034, and then the probability of choosing machine A and at the same time getting a defective light bulb in machine A is 0.5, because that's the probability of choosing machine A, they're equally likely, so 0.5 times binomial, the binomial probability of the variable when x equals 2. I'm going to use the formula in the function in the calculator, not the formula. So I'm going to use the binomial PDF function with 10 trials, 0.1 as my success probability, and 2 for my value of x. I'm gonna go to my calculator and write all of that. 0.5 times binomial PDF with 10 trials, probability of success 0.1, x value 2, paste. And now I'm going to divide by the value I got on the part A. To do that, you can type it. You can write 0.134, or you can go up, press enter, and then it pastes the result you got on the other part here. You save a little bit of time, and because you have more decimals, it's more exact. I'm going to press enter and see what I get. And I get 0.72187, etc., etc. That is my result then, and that is my answer for this question. So around 72% of getting 2 defective light bulbs, given that we picked machine A. And this is it for this video and for the series of binomial distributions. Where will come next? We could be, for example, start studying continuous random variables. And in there, working with normal distribution. I'm gonna have a whole series of videos about that, so I hope to see you there. Bye bye!